Okay, I welcome you all for this data science course session 3. So in this session we are going to look at a package called NumPy. Okay, the NumPy stands for numerical Python. This is one of the package which is used to work with n-dimensional arrays. Okay, normally in Python what you will do is we will be dealing with one-dimensional array or two-dimensional arrays. Okay, so using this NumPy we will be working with n-dimensional arrays. Okay, and one more advantage of going for this NumPy array is this is very faster than the normal arrays. Okay, the normal arrays in the sense the normal list. Okay, so how it is faster is, for example, as you can see here, NumPy aims to provide an array object that is up to 50 times faster than the traditional Python list. For example, if you are creating a normal Python list with 10 numbers, okay, and if you are creating a NumPy array with again some other 10 numbers, then there may not be any difference. Okay, for example, imagine you are having an array of 10,000 numbers or 10 lakh numbers. Okay, then if you are trying to perform some operation on the 10 lakh numbers, okay, using a normal Python list, then it may take more time. Okay, but if you are creating the same 10 lakh numbers array as a NumPy array, and if you are trying to do the same operation with the NumPy array, then it takes very less time. Okay, so that's why we are going for NumPy arrays. Okay, so as I said already, it is used to create any dimensional array, n-dimensional array, any number of dimensions it will support. Okay, so how do you install NumPy? The standard installation command you can use, pip install, then give the package name, that is NumPy. Okay, so this command will install the NumPy package into your Python. Okay, so this is a very simple example which shows how to create a NumPy array. Okay, so as you can see, this is import NumPy as NP. NP is the short name for the NumPy. You can give your own name. Okay, it's not necessary that you have to give only NP. You can give any name. So then I am creating an array, NP dot array. Okay, with some numbers here, 1 2 3 4 5. Okay, so now this array is going to be a NumPy array. Okay, and it is stored in the variable error. Okay, then I am just printing the array and I am just printing the type of the array. Okay, let's see what is the output of this. Just what we are doing here is we are just creating an array. Okay, just we are creating an array and just printing the array and then the type of the array, nothing else. Okay, so now I'll open this NumPy notepad. So just go to Colab, create a notebook. If you are working on a new notebook, then you just use the code whatever displayed here, and we'll try to get the output whatever we are doing. Okay, so as you can see here, so this is my code whatever I have shown there. Okay, so this is my NumPy array. Okay, I'm just printing the array, then data type of the array, D type is data type of the array, then n dimensional is nothing but the number of dimensions of the array, and then array of 2. Array of 2 is just to show you how to extract the numbers from the array. It's like normal indexing. Okay, how do you do it in your C, C++, Java or Python? Okay, how to get the numbers. Okay, now the output of the first line, print array, so the output of this is just the array contents. Okay, then the output of the second line is data type, that is the integer. Okay, integer 64-bit. Okay, then the output of the third line is the number of dimensions. You can see there is a one dimension. Okay, because It's a normal simple array. It has only one dimension. There is no row column. Only if you have row column, you will have two dimensions. Okay, for matrix. Then the last output is I am printing array of 2. Array of 2 is this is my index 0, index 1, this is index 2. Okay, so your output is 3. Okay, so like that you can get the numbers using an index. Okay, so this is simple array with which we have shown some of the outputs. Simple numpy array we have created. Okay, then the next one, in this example, see, I have supplied a list here. When you enclose the numbers within a square bracket, that is called list. Okay, so the list is supplied here and it is created as a numpy array. And similarly, you can supply the tuples. Tuples, if you know basic Python, you might be aware of what is tuple. Tuple is nothing but the same content we are enclosing in normal brackets. Okay, so I am passing a tuple and I am creating an numpy array. Okay, otherwise the same contents will be there. Okay, nothing special. This is just to show you I can supply the list and I can create an array, and I can supply the tuple and I can create an array. Okay, then I am creating a 2D array. See here, this is my 1 2 3, that is the first row, and this is my second row. Okay, 2D array means it's nothing but a matrix. Okay, where you will have row and column. Okay, you can see from the output here, this is my two-dimensional array. So I have 1 2 3 4, row 1, and this is my second row, 5 6 7 8. You can see the output here. Okay, just create an array np.array. See, if you are having two dimensional matrix, you will have two brackets. Okay, and similarly here also two brackets. Okay, okay, now how to get the dimension of the array? You can give this array dot n time, that will give you the output 2. Okay, so the first output is just printing the array. Okay, it's a two-dimensional array, so it will print it as row and column. Okay, so 1 2 3 4 is the first row and 5 6 7 8 is the second row. Usually this is called row 0. Okay, and this is row 1. Okay, and similarly this is column 0, and this is column 1, and this is column 2, and this is column 3. Okay, now for example I want to get this element 8. Okay, so what should I give? I will have to print array of row number 1 comma 3. Okay, so that will give you the output 8. Okay, so for example now if I give array of 1 comma 3, so first time I am running it up, it will take some time. So you can see the output is 8. Okay, so if you want to print for example 3, so this is row 0 and column 0 1 2. Okay, so 0 comma 2. So you can see the output is 3. Okay, so this is how you can read the elements from the array. Okay, and similarly you can go for 3-dimensional array where you will have 3 subscripts. You can see here. Okay, 1 2 3 4 5 6, then 11 22 33, and this is my first matrix and this is my second matrix. 3-dimensional array you can imagine as a set of matrices. Okay, 2-dimensional array you are going to consider it as row and column, and when you go for 3-dimensional array you can consider it as a set of matrices which is put inside an array. Okay, you can see from this output you will be able to understand. So this is my first matrix. Okay, So this is my second matrix. Okay, so this is my 0 element and this is my element 1. Okay, so inside this I have again row and column. So this is my row 0 and this is my row 1. Okay, and here again inside this first element I have row 0 and row 1. Okay, so when I try to print 0 comma 1 comma 2, what's happening is the element 0, this is my element 0, first matrix, it will go to this. Okay, so inside this matrix it will be taking 1 comma 2. Okay, so 1 is row, so this is row 1, 2 is the column number. You can see this is 0th column, 1 column, and this is second column. Okay, so this is your output 6. You can see the output here, that is 6. Okay, so this is how you will be extracting the elements from the three-dimensional array. Okay, now the next we are moving on to slicing. Slicing is nothing but cutting the elements of the array, cutting, or you can say extracting the required elements from the array. Okay, now this is my array. You can consider I have 11, 12 till 77. Okay, now when I do this array of 1 colon 6, 1 is the starting position and 6 is the ending position. Okay, actually when I specify 6, it will print only up to index 5. Okay, always it will print one index less than the given index. Okay, if I specify 1 colon 6, it will print from 1 to 5 only. If I specify 1 colon 10, it will print only from 1 to 9. Okay, so your output will be the index 0 is this is index 0, so this is index 1. So it will start from here, and this is 2, 3, 4, and this is index 5. Okay, now let's check the output of the first one. You can see here from 22, 33 till you are getting 66. Okay, so it will not go to the 6th element, it will remain till 5th element, 5th index only. Okay, now come to the second one. Here I have specified 4 colon, there is no ending element. Okay, starting position only specified, there is no ending position specified. So what it will do, this is index 0, 1, 2, 3, 4. So it will start from here and it will go till the end. Why? Because there is no ending position specified. So that's why you are getting this output 55, 66, 77. Okay, now the next case is the reverse case. There is no starting element specified, only the ending element is specified. So what will happen? So it will start from the beginning. If starting is not mentioned, so it will start from the beginning. It will go till 4. 4 means 4 minus 1, 3. Till the index 3 only it will go. Okay, so 0, 1, 2, 3. So this till this position I am getting the output 11, 22, 33, 44. Okay. Okay, so this is about the forward indexing. The next comes reverse indexing. Okay, reverse indexing is nothing but when I give array of -1, what happens is the indexing starts from the right side. Okay, so this is my index -1 and this is -2 and this is -3 and this is -4. It goes like this. Okay, -5, -6, and this is my -7, the last element. Okay, so when I give -1, it prints only 77. This is my output. Okay, for this print statement my output is 77. Okay, Then I am using print array of -3 to -1. Okay, so -3, this is -1, -2, -3, this is -3. So I am starting from here till -1. -1 means -1, one index less than that. Okay, this is -1, so you will have to subtract from that one index, so it will be from till this point. Okay, -1 -1, you will get -2, so this is my -2, so it will print from only -3 to -2. Okay, the last index it will not print. Okay, so you can see the output here. So it prints only 55, 66. This is my output. Okay, then array of 1 colon 6 colon 2. Okay, normally we will be seeing at starting position and ending position, but here there is some extra number available here. So what is this? So 1 is the starting position, so I am starting at this position. This is 0 index, this is 1, so it will start from here 22, there is no doubt. Okay, and it will end at 6. 6 is the index 1, and then this is index 2, this is index 3, index 4, index 5, index 6. So this is my index 6. Index 6 is always one index less than that. Okay, so it will print only up to this. Okay, but there is an extra argument mentioned here, that is called 2. So what is this 2? This 2 is nothing but it is going to increment the index by 2. Okay, for example, I am starting with this index 1. My next index will be 1 plus 2. So 1 plus 2, 3. So next is the third index. Okay, so it is printing the third element, third index. So the third index will be 44. So that's why it is printing 44. The next index will be 2. Sorry, this is index 1 plus 2. This is third index. Then 3 plus 2, 5. So this is my fifth index. Okay, this. So it's printing 66 also. Okay, so that's why so that 2 is the incrementation in the index position. Okay, so if I specify 3, it will increment the index by 333. Okay, so the third argument shows the increment, just like how do you do it in your for loops. Okay, so that is the index, increment of the index. Okay, then there is a concept called copy, array copy. Now you can see this is the original array. I am taking a copy of the array, array.copy, and I am storing it in a variable called x. Okay, then after taking the copy, you can see I am modifying this array, array of 0 equal to 42. So what is happening here? Array of 0 is nothing but this element. Okay, so the first element will be modified as 42. Okay, after modification I am printing the original array and then x. X is having the copy of the array. Okay, now let's see what happens. As you can see, when I print the original array, it shows the modified copy because I have modified here array of 0 equal to 42. But when I print the copy, it is showing the old data. Okay, because before modifying I have taken the copy. Okay, so that's why it is not reflected here. Okay, so when you take a copy, after taking the copy, whatever the modifications you are doing, that will not be reflected in the copy of the data. Okay, no, I don't want like that. I want to reflect the changes. Okay, I want to do like that. Then what should you do? Then there is a concept called view. Okay, so here what happens is, instead of taking a copy, we are going to take the view of the original data. So this is the original data. Here I am creating a view, array.view. Then I am changing here. Okay, then you print array and x. Now see what is happening. This is the original array and this is the view of the array. Okay, so whatever the changes you are making in the original array, that will be reflected in the view, that whatever you are creating here. Okay, so that is the difference between copy and view. Okay. Okay, the next is shape. How do you get the shape of the array? You have a function called shape, array dot shape. So that will give you the shape of the array. This is my two-dimensional array. 1 2 3 5 6 7. 1 2 3 is the first row and 5 6 7 is the second row. So as you can see, there are two rows, that is 2, and 3 is the number of columns. Okay, it's a 2 by 3 matrix, you can see. So that is the output of this function, array dot shape. Okay, the next one we have is reshape. Okay, now there is an array and I am going to reshape this array in different ways. Okay, you can see this is the original array 1 to 12. It is having the numbers from 1 to 12. I am going to reshape this array with this dimension 2 comma 6. Array dot reshape 2 comma 6. Okay, now 2 is the number of rows and 6 is the number of columns. Okay, so when you execute this, you will get the output like this. There are 2 rows and 6 columns. First 6 numbers will be row 1, the next 6 numbers will be next row. Okay, then I can do reshape like this also, 2 comma 3 comma 2. It's a 3-dimensional array. You can do reshaping in whatever the way you want. Okay, so 2 comma 3 comma 2 is, it's a 3-dimensional array where you'll have 2 matrices, each matrix is of size 3 comma 2. Okay, if you look at the output, you will be able to understand here. Okay, I have this is my 3-dimensional array and I have 2 matrices. This is my first matrix and this is my second matrix. Each matrix is of size 3 rows and 2 columns. Okay, so that's what given here, the reshape. 2 matrices, each of 3 comma 2 size. Okay, so that is the 3-dimensional array. Then iterating is nothing but if you want to print the numbers in the array one by one, I can go for a for loop. Okay, so I can use the for loop and I can print the numbers one by one like this. So this is the simple array. Run a for loop for x in array, then you print x. So what it does is, it takes the elements one by one from the array and it prints like this, 1 2 3 line by line. If you print the entire array using a variable name, print array means what will happen, it will print as a list. See, you can see the output here. If you want to print as a list, I can go for normal print array. Okay, but I don't want to print like that. I want to extract the numbers one by one from the array and I want to print. Then I have to do it like this. I have to use for loop and you have to print one by one. Okay, so this is a single dimensional array. Similarly, you have to do it for 2-dimensional array. So 2-dimensional array means what you do, you'll for example in your C or C++, what you do is you'll use a 2 for loop. Okay, for example, if you are going for some matrix addition or subtraction or multiplication, you will use 2 for loops, right? For I equal to 1 to n, and then inside that for loop you will write for j equal to 1 to n. Okay, in the same manner, outer for loop will be for x in array. It will take row by row. X in array means it will take row by row, and the second for loop will take for y in x. It will take the elements from the row one by one. Okay, so first in the x, row 1 will come. So it will go inside the second for loop, then it will take the elements one by one from this array and then it will print. Next time in the x, the second row will come Next again it will take the elements one by one from this row and it will print. Okay, so that is for two-dimensional array. And similarly, if you go for three-dimensional array, you will have to use three for loops. You can see here. Okay, first for x in array, then for y in x, then again for z in y. Okay, so this is the way you will have to use nested for loops to extract from the three-dimensional array. Okay. Okay, then we'll see something about how to join the two arrays. Okay, I have a function called concatenate. Okay, one second. Okay, so using this concatenate function, I will be joining the two arrays. Okay, so this is my first array, array 1, and this is my second array. Okay, so just use this concatenate function and supply array 1 comma array 2, it will join the two arrays. Okay, so your output will be like this. Okay, so when you go for two-dimensional array, so this is my first row and this is my second row, and there is another matrix which is having 5 comma 6 and 7 comma 8. There are two matrices available here. Okay, 1 comma 2, 3 comma 4, 2 by 2 matrix. Okay, and 5 comma 6 and 7 comma 8, that is another matrix. If you want, I will print two arrays and I will show you. Print array 1, then print array 2. Okay, so this is my two matrices. Okay, okay, now I am going to concatenate this array 1 comma array 2 using this axis equal to 1. So when I specify axis equal to 1, what is happening? The numbers are concatenating like this: 1, 2, 3, 4, and it will take these two columns and it will combine here 5, 6, 7, 8. Okay, so when I specify axis equal to 0, it will combine row wise. You can see the output now. See the output: 1, 2, 3, 4. That is my original array: 1, 2, 3, 4. And then I have 5, 6, 7, 8. Okay, so that is my second row. Okay, so using this axis, we are trying to combine the matrices this way. Okay, so when I put axis equal to 1, it will combine column wise, and if you put axis equal to 0, it will combine row wise. Okay, okay, then there is a function called horizontal stack and vertical stack. Okay, you can use this also to combine the arrays. So I have elements 1, 2, 3 and 4, 5, 6. Okay, I am using this horizontal stack and I am combining these two. You can see the output. It combines horizontally 1, 2, 3, 4, 5, 6. Okay, then I have a function called vertical stack, V stack. Okay, it combines vertically. So you can see this is my array 1 2 3 and this is 4 5 6. See, it combines like rows. This is my first row and this is my second row. Okay. Then we have a split function. So this is used to split a given array. Okay. So this is the original array 1 2 3 4 5 6. Okay. And we are going to split this array into a number of arrays. Okay. For example, I am going to split this into 3 arrays. Let's see what happens. Okay. We are having 6 elements here. So 1 2 is the first array and 3 4 is the second array and 5 6 is the third array. Okay. So for example, I want to split this into four arrays. Then what will happen? 1 2 first array, 3 4 second array. Then there is no sufficient element to split it into 4 arrays, like 2 elements. So what is happening? By default it will take 1 elements, 5 and 6. Okay, so that you can create 4 arrays. If I specify 5, I want to split this array into 5 arrays. Then see, only the first array is having 2 elements. Okay, the other arrays are having 1 element, 3 4 5 6. Okay, so that is the way it gets adjusted automatically. Okay, so that is about splitting the array. Then we'll come to searching the array. Okay, so in searching, what happens is either you can use you can search for a number, or I can search using some conditions also. Okay, so first thing, let's see about using a number. Okay, so this is my array and I am going to search for a number 4. Okay, so what I have to do, I have to use this function np dot where array equal to the number 4. Okay, now what will happen, wherever the number 4 is present, okay, wherever the number 4 is present, that will print only that indexes. Okay, you can see this is index 0 1 2 3. So index 3 is here, my output, and 4 5, this is index 5, index 6. Okay, so my output is 3 5 6. Okay, because you are searching for 4, the 4 is available in that indexes. Okay, so your output will be only that index positions. Okay, next I have I am trying to search using a condition. Okay, you can see from here I have a condition called array mod 5 equal to 0. Okay, so I am searching for a number which is divisible by 5. Array mod 5 equal to 0 means what? When you divide a number by 5, you should get the remainder 0. Okay, so that is what the mod operation is actually. Okay, so when I divide a number by 5, I should get the remainder 0. It means I am searching for a multiples of number 5. Okay, you can see from this array I have 10, then 45. Yeah, that's all, only 2 numbers. 10 is multiple of 5 and 45 is multiple of 5. That is, when I divide 10 by 5, I will get remainder 0. When I divide 45 by 5, I will get remainder 0. When you divide other numbers, for example 22, 31, you will not get the remainder as 0. Okay, so only when I get the remainder 0, that numbers will be extracted. Okay, so this is my index 0 and 1 2 3, this is my index 3. Okay, so these 2 indexes will be printed here. Okay, so that is another way of searching. Either you can give the numbers directly and search, or you can give the indexes and search. You can give the condition and search, like this kind of conditions. Okay, now the another function we have is search. search, okay, uh, here there is a variation of function search sorted. Search sorted means what will happen, it will first sort the numbers that is given. Okay, so what is the numbers given here? 6, 9, 8, 7. First arrange the numbers in the order 6, 7, 8, 9, that is the order. Okay, then you will have to search for the number 7. Okay, search sorted inside the array ARR comma the number which you are going to search. Okay, so I am searching for 7 after arranging the numbers. Okay, so after sorted means arranging the numbers in the order. Okay, so 6, 7, 8, 9. So 7 is available in the second position. Second position means index 1. So that's why it is printing index 1. Actually it is available at the index 3, 0, 1, 2, 3. But after sorting, the 7 will come here. 6, 7, 8, 9. So that's why you are getting the output as 1. Okay, so that is called actually search sorted. Okay, and you can see here search sorted, I am looking for the same number 7, but I am searching from the right side. Okay, side equal to right. Okay, now these numbers are already in the order, so it is sorted already. So this is my index 0, 1, 2. So that's why you are getting the index 2. Okay, we are searching from the right side. Okay, so index 0, 1, 2. Okay, so that is index 2. Then I have a function called sort, which will do the sorting. Sorting is nothing but arranging the numbers in the order. Okay, so just this is my numbers, just apply this function np.sort, give the array name. Okay, so that will do the job. So it will sort the numbers in the order. Okay, search sorted is searching for a particular number in the sorted array. After sorting the array, it will search. Okay, sort will do only the sorting, just arranging only it will do. It will not search for the number. Okay, this sorting will do for alphabets also. See here, this is my strings. Okay, I can sort the strings also. Alphabetical order it will sort. Okay, and similarly you can sort the two-dimensional matrices also. What will happen is it will sort row by row, 2, 3, 4 and then 0, 1, 5. So you can see the output here, 2, 3, 4 and 0, 1. Okay, so then we have a concept called filter. Okay, in the filter what is happening, so this is my numbers 41, 42, 43, 44 and this is my filter, true, false. Okay, so wherever I am having true, that numbers alone gets filtered. Okay, so true is like a filter. Okay, so the respective indexes will get printed here. True, 41 will come. Next I have false, so 42 will not come. Next I have true, so 43 will come. Next I have true, next 44 also will come. Only wherever you are having false, that data will be removed. Okay, so when you look at your output, you are getting 41, 43 and 44. Okay, so for 42 I have false, so that will not come as the output. Okay, so that is called filters using the filter array. Okay, the filters you can apply using condition also. Okay, as you can see here, so this is my original array and I am applying a filter here. What is that filter? Filter array equal to array greater than 42. Okay, that condition is the filter. Okay, so array greater than 42 means it will print only the numbers greater than 42, 43, 44. Now I am going to apply this filter to this array. Okay, what I have to do, give new array equal to array of filter array. Okay, then you print the output. First you print the filter array. So what is the condition given in the filter array? Array greater than 42. So in that case, this is false, this is false, this is true, and this is true. So that is what the output here, filter array. Okay, so when I apply this filter onto this data, wherever I am having false, that will not come. So 41, 42 will not come. So your output is only 43 and 44. Okay, that is array greater than 42. Okay, that is one way. The another example shows here is I can extract with this kind of conditions also. Filter array equal to array mod 2 equal to 0. It means that the multiples of 2. Multiples of 2 means even numbers. 2, 4, 6, 8. Only that numbers gets printed here. Okay. So this is my original array. So I am applying this filter, array mod 2 equal to 0. So your filter will be applied on these numbers. Okay. So 1 mod 2 equal to 0. No, it is not true. 1 mod 2, if you do it, you will get the answer 1. Okay. 2 mod 2 is 0. So this is true. And 3 mod 2 is 1. So that will not come. This is false. This is true. 4 mod 2 equal to 0, because when you divide 4 by 2 you will get remainder 0. Okay, 5 mod 2 equal to 1. 5 by 2 you will get the remainder as 1. Okay, so that is false. 6 is true, 7 is false. So that is the filter array we have created. Okay, with this filter array I am trying to filter these numbers. Okay, then what will happen? It will print only wherever I am having true. Okay, so where I am having true, this 2, 4, 6. Okay, 2, 4, 6. Clear? So that is the way you can apply the filters using conditions like this. Okay, so this is about NumPy package. So like this you will have a lot of functions inside your NumPy library. So with this introduction you can explore more functions on the NumPy package. Okay, so I'll stop with this for this session, and let's continue in the next session with some other package. Okay, thank you.